Okay, so this week kita continue with chapter 2, flow of water through the soil or permeability. So I expect you already watch the video yang I share earlier, yang ada a few type of soil and then dia tuang air dekat atas dia and then to check how much water and then the time taken and the collection of water after the water passing through the soil. Alright, okay, so the aim is actually to identify or to measure the permeability of soil. So what is the permeability? So permeability, first kita tengok dia punya definition, okay? The capacity of soil to allow water to flow through it, or how is water flow within soil mass. Maknanya how is once water infiltrate masuk dalam tanah and then dia akan flowing dalam tanah and supposedly dia akan keluar semula. Okay, so kita akan tengok how is kalau dia laju aliran and then dia keluar tu cepat, it means that they have good permeability. Okay, permeable soil. Kalau once air masuk, dia akan duduk dalam soil tu lama, and then baru dia keluar, that one is impermeable atau low permeability dia. Right? Okay, so before we go detail on the soil mobility, so kita tengok on the equation. Alright, so flowing of water according to Bernoulli equation. Kalau tengok due to Bernoulli equation, flow of water, tekanan di dalam air kita panggil dia pressure, ataupun total head kita panggil total head. The total pressure of water kita panggil total head, which is H. Okay. So kalau the flowing of water, tak kira lah dalam medium apa, okay, tak semesti tanah, dia kata secara general, according to Bernoulli. So H, total head, total flow of water pressure, is equal to Hz plus U over gamma W plus V square over 2G, which is Hz refer to elevation, difference level. Maksudnya air will flowing from the higher level to the lower level, and then U over gamma W due to the presence of pore water pressure. Okay, which is gamma W adalah unit weight of water, and then U is the pore pressure lah, pore water pressure, and then V square over 2G, V due to velocity, which is velocity were related with the gravity. So semakin steep slope satu gravity, semakin cerun air semakin laju, velocity laju dia semakin tinggi. Tapi bila aliran air daripada kawasan yang landai, so velocity dia agak perlahan. Alright. Okay, so itu maksud Bernoulli equation. But then kalau kita fokus on the flow of water through soil, so now kita fokus lebih kepada soil, the equation will be H sama juga dengan Hz plus U gamma W. Okay, so you see kita ignore element of V square over 2G. Why? Because V is quite small owing to high resistance to flow offered by granular structure. Okay, sebab kita tengok flow of water through soil sekarang ni, so we know that in the component of soil body kan dia ada particle granular solid-solid tu. Okay, so that solid tu akan bagi halangan kepada kelajuan air. So that's why V is quite small. Okay, disebabkan oleh granular structure tadi. So that's why bila flow of water through soil, H sama je dengan Hz plus U over gamma W. Tak ada element of velocity due to gravity. Okay, so the permeability, lepas kita tengok Bernoulli equation tadi, it's also related with the Darcys Law, with the Darcys Law. Referring to the one-dimensional flow of water. Dekat gambar ni. So this picture. Okay, so we have the soil sample. Okay, the movement of soil sample. We can see that is from the higher level to the lower level. Okay. So water will flow, okay, dari higher level kat sini, dia akan masuk, mengalir, and then coming out at here. So when we tap with the manometer, okay, so kita tap dengan manometer, samalah yang ni, yang ni pun manometer. So kita akan tengok there is delta H different antara H1 to the H2. Alright, and then we have the distance, the path, the laluan of the water, okay, which is L, delta L, and we also know the area, the area of the soil sample, okay, and at the end once water masuk in, and then it will coming out here. So we can collect the volume of the water at certain time. So we will have the quantity actually. Okay. So based on this diagram, kita come out dengan hydraulic gradient. Set the movement of water related with the hydraulic gradient. I sama juga dengan H over L. So H is the head loss, and L adalah length of path, laluan water. So from the Darcys Law, we have V sama juga dengan KI. Okay, V dia punya velocity, K adalah coefficient, okay, and I is the hydraulic gradient. So I equivalent to H over L. Okay, so when we substitute K and then H over L kat sini, I with the H over L, so we have V sama juga dengan K, H over L. Okay, so nanti kita nak tengok what is the K dekat sini. K. So what is K? K adalah coefficient of permeability. Okay, ataupun hydraulic conductivity. Certain books they guna term hydraulic conductivity, and but the definition is the same. K is the coefficient of permeability, K also the hydraulic conductivity. So in order to measure the permeability, so the measurement are based on the K value. Okay, the measurement are based on the K value. So how to get the K value? Okay, it can get from the lab work and also field work. Okay, so the data nanti yang kita akan analyse sama ada from the lab work and also from the field work. So we have the constant head test untuk dapatkan the K value from the coarse soil, whether it gravel or sand, and we have the falling head test for the fine soil. So the unit of the K value nanti adalah distance over masa, time. So whether in mm per second, mm per minute, it can be meter per hour. So it depends what unit that we want to identify the K value. Okay, so hari ni kita fokus on the constant head dulu. So hari ni kita nak tengok untuk constant head soil dulu. Alright, okay, so this is the arrangements of the constant head test for the lab work. So kita tahu that the constant head test adalah for the coarse soil, whether it's sand ataupun gravel. So constant head test is suitable for sand and gravel. So this is the diagram of the setting up alat dia. Okay, kita tengok prosedur dia sikit. Okay, the valve A and B are open. So we have valve A dekat sini and valve B here. Valve C, kita nak keluarkan bubble. Before we start, kalau ada bubble kita buka dulu valve C. Okay, dah clear the bubble, then you close the valve C. Alright, okay, then once we want to start, the air water ni normally kita sambung dengan tap water, air pipe lah ya. Okay, once kita buka the tap water, and then ensure that valve A and B also open. Okay, and then kita allow water to flow. So air akan mengalir melalui laluan itu, and then dia akan masuk sampel. So dalam ni adalah sampel, sampel tanah, sama ada it's sand ataupun gravel. Alright, so bila nak record the data, we need to ensure that the flowing of water tu in a steady state. Steady state ni, in a steady state maksudnya level in manometer remain constant. Okay, so there are manometer, ada dua tube manometer dekat sini. Okay, once the level dia constant, maksudnya antara dua level ni dia dah tak bergerak lagi, remain stable kat situ, and then baru kita recordkan the H difference in manometer level dia. Okay, manometer yang pertama ni berapa, manometer kedua berapa, untuk dapatkan dia punya H difference. And then knowing that we tap 2 point kat sini tadi, untuk pasang manometer kita ada tap 2 point, so itu kita panggil tapping point. We also measure the distance between tapping point, kita dapatkan jarak tapping point, and then kita rekodkan lah dia punya nilai Q kat sini, berapa kuantiti air yang keluar Q dalam masa yang kita tetapkan nak tengok, and then kita rekod dia punya bacaan dia. Alright, so the diameter of the sample, kat sini we need to know the diameter of the sample. Normally given the diameter of the sample, we can calculate dia punya area. The area of sample is equal to pi d square over 4. Okay, so this is the equation. Kita nak generate the equation. So from the Darcys Law, we have V sama dengan KI, Q sama dengan VA, Q also equal to Q over T. So ini more to mathematics, kita just rearrange. 2 sama juga dengan 3, since dua-dua adalah Q, so Q over T sama juga dengan V over A. Alright, and then kita substitute, substitute the Q over T ni sama juga dengan KIA, because V dekat sini adalah sama dengan KIA. Okay, so KIA darab dengan A. Okay, so we have the I here, so I also substitute dengan H over L. So kita akan dapat Q over T sama dengan KH over L times dengan A. So we just rearrange to get the K kat depan sini, so kita dapatlah QL over AHT. So Q is the volume or the quantity of water collected, L distance between manometer tapping point, A is the area, H is the difference in manometer level, and T adalah duration or the time taken. Okay, kita tengok satu example. A constant head per meter test had been run on a sand sample. Kita tahu this one for the coarse soil, 150 mm in length. So jot down the info. 2000 mm square in area. So kita tahu area. Head loss is the H value, different levels, kat sini different in manometer level is H loss. And then we also collect the discharge yang keluar tadi, 250 ml, and time taken or duration 145 second. So kita akan guna this equation, Q sama dengan QL, K sama juga dengan QL over AHT. So unit mana yang tak setara, we need to tukar the unit. So obviously Q unit dia tak setara because it use ml. So kita kena substitute guna mm cube. Kenapa mm? Because the rest of the unit yang kita guna adalah mm. So kita buat sikit conversion unit. 1 ml sama juga dengan 1000 mm cube. So 250 akan sama juga dengan ini. And the rest dah settle. So kita just masuk dalam equation. Q kita dah tukar 250 mm cube, L 150 kat sini. And then over AHT area 2000, H 5 450 and the T adalah 145 second. Okay, you calculate and then you akan dapat this answer. Alright. Okay. And then ini another example. Sama juga data given duration of the test, which is the T. Quality of water collected 3 to 5 ml. Head difference is H value. Distance between manometer tapping is L value. Diameter of the test sample is D lah. This one is a D to get the area later. So mana unit tak setara? We need to convert to the suitable unit. So ml to mm cube. Okay. And then we need to calculate the area because area not given, but then the diameter is given. So A sama dengan pi d squared over 4. So this is the area for the sample. Straightforward, masuk dalam this equation. We have the Q, we have the L, and then A, H, T. Okay, since soalan nak mm per second, so from 4.5 minute kita tukar kepada second. Okay, which is 270 second. So kita tukar second kat sini. So this is the answer.